Alright, so AI. It's a term that's these days, right? You hear it constantly, in tech news, in product announcements, even in casual conversations about the future. From the smart assistant on your phone to the algorithms recommending your next binge watch, artificial intelligence is quietly, and sometimes not so quietly, reshaping how we interact with technology and the world around us. But with all the buzz, there's also a lot of confusion. What does it mean? How does it really work? And what's hype versus reality? That's what we're diving into today. Welcome to our video on artificial intelligence. Today, we'll be answering 10 essential questions about AI that everyone should know. We're not just going to skim the surface, we're going to break down some of the core concepts, look at tangible, real-world examples that you're probably already using, and even touch on some of the bigger picture questions like its potential, its future, and yes, the ever-present question about whether it's coming for our jobs. My goal here is to give you a solid foundation, a clear understanding so you can cut through the noise. So, if you've ever been curious about what AI truly entails, or how it's already impacting your life, or what to expect in the years to come, you're in the right place. We've got a lot to cover, from the basics of machine learning to the ethics of AI development. Stick around, because by the end of this, you'll have a much clearer picture of what AI is all about. No advanced degree required. We're aiming for clarity and real insight. Let's get into it. Alright, first up, what artificial intelligence? You hear AI, a buzzword thrown around constantly, but what are we actually talking about when we strip away the hype and the sci-fi movie portrayals? At its very core, AI refers to computer systems. That's the software, the complex algorithms, the powerful hardware, the whole technological package, specifically designed and meticulously programmed to perform tasks that, until recently, were thought to exclusively require human intelligence. Think about the sophisticated cognitive functions humans perform daily, learning from past experiences and mistakes, reasoning through intricate and multifaceted problems, making critical and timely decisions, understanding the nuances of human language, or even just perceiving and interpreting the complex world around them visually or audibly. We're not just talking about simple automation here, like a basic script or a macro in a spreadsheet. We're discussing systems that can adapt, evolve their responses, and, in a very real sense, think, or at least convincingly simulate the process of thinking to achieve specific goals. The main objective here, in a vast number of applications, is to automate incredibly complex processes that would otherwise consume a tremendous amount of human time, resources, and effort, or might even be entirely beyond human capability when you consider the sheer scale, speed, or precision required. A significant and foundational part of achieving this automation and intelligence is enabling these systems to make highly accurate predictions or classifications based on analyzing vast quantities of data. So, AI ingests and meticulously processes enormous data sets, identifying subtle patterns, hidden correlations, and underlying trends that human analysts might easily overlook or take much longer to find. It then leverages these discovered patterns to forecast what might happen next with a certain degree of probability, or to make an informed, data-driven decision that optimizes for a desired outcome. It's a remarkably broad and rapidly evolving field, encompassing many sub-disciplines, but that's the fundamental idea: empowering computers to mimic and eventually even surpass intelligent human behavior in specific, well-defined domains. So, if AI is about mimicking human intelligence, a big part of that is learning. But how does a machine, a piece of code actually? It's not like it's sitting in a classroom, right? Well, the primary mechanism AI uses to learn is a field called machine learning, or ML. This is where it gets really interesting. Instead of explicitly programming a computer for every single possible scenario, which would be impossible for complex tasks, machine learning algorithms are designed to analyze large volumes of data, identify recurring patterns, statistical relationships, and significant features within that data. Think of it like showing a child thousands of pictures of cats. Eventually, they start to recognize what makes a cat, without you listing every single defining feature. These algorithms essentially build a mathematical model based on the input data they're trained on. Over time, and with more and more relevant data fed into the system during this training phase, the AI model iteratively refines its understanding and improves its ability to make accurate predictions, classifications, or decisions when presented with new, unseen data. It's a continuous feedback loop. If it makes a mistake, that mistake, and the correct answer, can be fed back into the system to help it learn and adjust its internal parameters. This process is very much analogous to how humans learn from experience. We try something, see the result, and adjust our approach for next time. The more diverse and representative the training data, the more robust and generalizable the AI's learning becomes, allowing it to handle a wider range of inputs and situations effectively. It's this ability to learn and adapt from data that makes AI so powerful and versatile. Okay, so we know what AI is and a bit about how it learns. But where is this technology actually showing up? Is it all just research labs and sci-fi, or is it stuff we're using every day? The answer is it's definitely the latter, and probably in more places than you realize. One of the most common examples is virtual assistants. Think about Siri on your iPhone, Google Assistant on Android, or Alexa in your smart speaker. These systems use AI, specifically natural language processing and machine learning, to understand your voice commands, fetch information, set reminders, and control your smart home devices. They're constantly learning from millions of interactions to get better at understanding different accents, phrasings, and intentions. It's a pretty seamless integration of AI into daily routines for many, but it goes way beyond just voice commands. In the financial world, AI is a powerhouse for fraud detection. Banks and credit card companies use sophisticated machine learning models to analyze transaction patterns in real time, flagging suspicious activities that deviate from your normal spending behavior, often stopping fraud before you even notice. Then there are autonomous vehicles. Self-driving cars from companies like Tesla, Waymo, and others heavily rely on AI for perception, decision-making, and control, using sensors and cameras to navigate complex environments. In healthcare, AI is being used for medical diagnosis, helping doctors analyze medical images like X-rays and MRIs to detect diseases like cancer earlier and more accurately. And of course, those recommendation systems on Netflix, Spotify, or Amazon, that's AI learning your preferences and suggesting what you might like next. Even smart home automation, adjusting your thermostat or lights based on your habits, often has AI working behind the scenes. It's truly becoming embedded in the fabric of modern technology. Chapter 4. Machine Learning versus Deep Learning. What's the deal? Alright, we've mentioned machine learning a few times now, but you might also hear another term floating around: deep learning. Are they the same thing, interchangeable? Not quite, and it's a pretty important distinction to understand if you want to get a clearer picture of the AI landscape. So, machine learning, as we discussed, is the broader concept. It's the overarching field where AI models and systems are designed to learn from data without being explicitly programmed for each specific task. It encompasses a wide variety of algorithms and techniques, some simpler, some more complex, that allow computers to find patterns and make predictions. Think of machine learning as the entire toolbox available for building intelligent systems that learn. Deep learning, on the other hand, is a specific subset of machine learning. It's a specialized technique within ML that has become incredibly powerful and popular in recent years, largely responsible for many of the major AI breakthroughs we've seen. What makes deep learning distinct is its use of artificial neural networks with many layers, hence the deep part. These neural networks are architecturally inspired by the human brain structure, with interconnected nodes or neurons that process information in layers. Deep learning excels at analyzing extremely complex patterns from massive amounts of unstructured data, like images, audio, and text. So while traditional machine learning might need features to be manually engineered from the data, deep learning models can often learn these features automatically, directly from the raw input. It's particularly good for tasks like image recognition, natural language understanding, and speech synthesis. So, all deep learning is machine learning, but not all machine learning is deep learning. Chapter 5. Can AI actually be creative? This is a fascinating one, and something that often sparks a lot of debate. Can AI truly be creative? For a long time, creativity was seen as this uniquely human trait, something that machines could only imitate superficially. But the landscape is shifting, and the answer now is increasingly yes, AI can exhibit forms of creativity, and it's doing so in some pretty impressive ways. We're talking about AI systems that can generate original music across various genres, create stunning and often surreal artwork, write poetry, draft articles, and even come up with new product designs. It's not just regurgitating existing stuff, it's synthesizing and generating novel content based on what it has learned. The key technology behind a lot of this creative AI capability is something called generative models. You might have heard of models like GPT, Generative Pre-trained Transformer for Text Generation, or DALL-E, and Mid-Journey for Image Generation. These models are trained on vast datasets of existing human-created content, text, images, music, code, you name it. They learn the underlying patterns, styles, and structures within that data. Then, when prompted, they can generate new content that adheres to those learned patterns, but is still original in its specific composition. So, is it creative in the same way a human is, with intent and emotion? That's a deeper philosophical question. But in terms of producing novel and often compelling outputs that we would typically associate with creativity, AI is definitely making its mark and pushing boundaries. Chapter 6. The big question: will AI take our jobs? Alright, let's tackle the elephant in the room, the question that's on a lot of people's minds whenever AI comes up. Will AI replace human jobs? It's a valid concern, and the honest answer is nuanced. It's not a simple yes or no. There's no doubt that AI and automation are already transforming the job market, and they will continue to do so. Certain tasks, particularly those that are repetitive, predictable, and data-intensive, are prime candidates for automation by AI systems. We're seeing this in manufacturing with robotic arms, in data entry, in customer service with chatbots, and even in some aspects of logistics and transportation. So yes, some jobs, or at least specific tasks within jobs, will likely be diminished or evolve significantly. However, it's not all doom and gloom. Historically, technological advancements, while disruptive, have also led to the creation of entirely new job categories and industries that didn't exist before. AI is no different. It's creating new roles focused on developing, managing, and maintaining AI systems. AI specialists, data scientists, AI ethicists, machine learning engineers, and so on. Beyond that, AI can also augment human capabilities, making workers more productive and allowing them to focus on more complex, creative, and strategic aspects of their roles that require uniquely human skills like critical thinking, emotional intelligence, and complex problem solving. The key really is for individuals and society as a whole to adapt. This means focusing on continuous learning, developing skills that complement AI rather than directly compete with it, and fostering an environment that supports workforce transitions. It's more about a shift in the nature of work than a wholesale replacement. We interact with AI that seems to see and hear all the time: facial recognition, unlocking your phone voice assistants, understanding your commands. But how does a machine actually process images and sounds? It's not like it has eyes and ears in the human sense. This is where two really cool fields within AI come into play. Computer vision for seeing and speech recognition, a part of natural language processing for hearing. For image recognition, AI typically uses deep learning models, specifically convolutional neural networks or CNNs. These networks are trained on massive datasets of labeled images, millions of pictures of cats, dogs, cars, faces, you name it. The CNN learns to identify hierarchical patterns, from simple edges and textures in the early layers to more complex shapes and object parts in deeper layers, eventually being able to classify an entire image or identify specific objects within it. When it comes to hearing or speech recognition, AI systems leverage sophisticated algorithms and natural language processing, or NLP techniques. First, the analog sound waves of your voice are converted into a digital format. Then machine learning models, often recurrent neural networks or RNNs or transformer models, analyze these digital audio signals. They break down the speech into smaller units like phonemes, then try to match these sequences to words and phrases in their vocabulary. This process also involves understanding context, grammar, and sometimes even a bit of accent or dialect adaptation to accurately convert the spoken sound into text. From there, another layer of NLP can work to understand the meaning and intent behind that text, allowing the AI to respond appropriately. It's a complex pipeline, but it's what allows your devices to seemingly understand you. So, AI is powerful, it's transformative, but with great power comes, well, you know the saying, and it leads to a critical question: is AI dangerous? This isn't just about Terminator-style scenarios, though those make for good movies. The risks associated with AI are more nuanced and in some ways more immediate. One of the most significant concerns is bias in AI decision-making. If an AI system is trained on data that reflects existing societal biases, whether related to race, gender, or other characteristics, the AI can inadvertently learn and even amplify those biases. This can lead to unfair or discriminatory outcomes in areas like loan applications, hiring processes, or even criminal justice. It's a huge challenge to ensure fairness and equity in AI systems. Then there are major concerns around data privacy and security. AI systems, especially machine learning models, thrive on vast amounts of data. How this data is collected, stored, used, and protected is a massive ethical and practical issue. Misuse of personal data, surveillance capabilities, and the potential for AI-powered cyber attacks are all very real risks. There's also the question of accountability. If an AI system makes a mistake with serious consequences, who is responsible? The programmer, the user, the company that deployed it? These are complex legal and ethical quandaries. However, it's important to state that these risks don't mean AI is inherently bad. The key is responsible development and deployment, which involves creating strong ethical guidelines, robust regulatory frameworks, promoting transparency, and continuous research into AI safety and alignment. With careful consideration and proactive measures, the goal is to harness AI's benefits while mitigating its potential harms. We've covered a lot about what AI is and what it's doing now, but what about the crystal ball? What does the future of AI hold? Predicting the future is always tricky, especially with a technology that's evolving as rapidly as artificial intelligence, but we can definitely see some strong trends and exciting possibilities on the horizon. AI will undoubtedly continue to become more integrated into our daily lives, driving further automation in industries ranging from manufacturing and logistics to customer service and content creation. We can expect AI systems to become even more sophisticated, capable of handling more complex tasks, understanding context with greater nuance, and interacting with us in more natural and intuitive ways. Think more capable personal assistants, more adaptive learning platforms, and smarter cities. In specific fields, the impact could be truly transformative. In healthcare, AI is poised to revolutionize diagnostics, drug discovery, personalized medicine, and robotic surgery, potentially leading to better patient outcomes and more accessible care. For science and research, AI can accelerate discoveries by analyzing massive datasets in fields like genomics, climate science, and materials science. Space exploration will benefit from more autonomous probes and AI-assisted mission planning. We're also likely to see advancements in areas like generative AI, leading to even more sophisticated tools for creativity and content generation. However, this exciting future also underscores the critical need for ongoing dialogue about responsible development, ethical considerations, and ensuring that AI benefits all of humanity. The possibilities are vast, but navigating them wisely will be key. So, after all this, maybe your curiosity is piqued. Maybe you're thinking, this AI stuff is pretty fascinating, how could I actually start learning more about it, or even get involved? The good news is, it's more accessible than ever to begin your AI journey, even if you don't have a PhD in computer science. A great starting point for many is online courses. Platforms like Coursera, edX, Udacity, and even YouTube itself offer a wealth of introductory and advanced courses on machine learning fundamentals, Python programming, which is a very popular language for AI development, data science, and increasingly, AI ethics. Many of these are self-paced and some are even free, providing a structured way to build foundational knowledge. Beyond formal courses, getting hands-on experience is crucial. Don't be afraid to experiment with readily available AI tools and libraries like TensorFlow, PyTorch, or Scikit-learn. Start with small, manageable projects. Maybe try building a simple image classifier or a basic recommendation engine. There are tons of tutorials and open-source datasets available online. Reading research papers from conferences like NeuraPeace or ICML or following blogs from leading AI labs can help you stay updated on the latest advancements, though that might be a step for later. And importantly, engage with the community. Join forums, attend webinars or local meetups if possible. The field is collaborative, and learning from others is invaluable. The key is to start somewhere, be persistent, and keep building your skills step by step. Alright, so that's our deep dive into 10 essential questions about artificial intelligence. We've covered a lot of ground, from the fundamental definition of AI and how it learns, to to its real-world applications, the difference between machine learning and deep learning, its creative potential, and even some of the more pressing concerns about jobs and safety. My hope is that this has demystified AI a bit for you, giving you a clearer understanding of what this technology is, how it works, and the profound impact it's already having, and will continue to have, on our world. It's a field that's constantly pushing boundaries, and staying informed is key. The journey into understanding AI doesn't really end here. It's an ongoing process of learning and discovery, especially as the technology itself continues to evolve at such a rapid pace. Whether you're just curious, thinking about a career change, or wondering how AI will impact your industry, hopefully, this video has provided a solid foundation and perhaps sparked an interest to explore further. There are so many resources out there, and the community is incredibly active and welcoming to newcomers. Remember, the future isn't just something that happens to us, it's something we can all help shape, and understanding technologies like AI is a big part of that. Thanks for watching. If you found this video helpful, and I really hope you did, please do all the YouTube things. Don't forget to like, share it with anyone else who might be curious about AI, and definitely subscribe for more content on AI and technology. We'll be exploring more facets of this fascinating world in future videos. Let me know in the comments if you have other AI questions you'd like to see answered. See you next time.